I will place also start some. So good morning, everyone. Good morning from Greece, from on behalf of Hellenic Mediterranean University and of the Athena talks of the Athena European University. This is the second talk that we have this year. It's a great pleasure to have with us Professor Santiago Pozo, a photonics person. Always I'm feeling very nice when I welcome people working with lasers, since my PhD is in lasers. So I'm very happy on this. A few things about Santiago. Santiago has received, if I'm not mistaken, all his education in university in Vigo, a bachelor degree in engineering in mining in 2009, master in environmental technology in 2010, PhD in environmental technology 2013. We are very happy that he spent 1 year of his postdoctoral studies in Crete, where do we locate in Institute of Electronic Structures and Laser, continuing his work in using lasers for cultural heritage. It's one of the most prestigious laser centers that we have, and with a very good reputation regarding their work. So this shows also the quality of Santiago, because they are very demanding regarding who is going to work with them in all levels. So Santiago today is going to speak to us about how do we use lasers in order for cultural heritage. And we are here to listening you, Santiago, for the next 40 minutes. Thank you very much for your contribution. Santiago right now also is the Director of Internationalization in the University of Vigo. So I suspect that he's very busy also with administration work. So this makes our appreciation even higher for your contribution in our community. So Santiago, the floor is yours, and we are looking forward.
Okay, thank you. I will share the screen with you. So please let me know if you can see everything well. Yeah, it's okay?
Yeah, it's very okay.
Okay, perfect. So first of all, thank you very much, Professor Kostas Petridis, for your introduction. For me, it's a real pleasure to be here, to be part of this great initiative by our European University, the Athena Talks. I am involved in the Athena activity since the University of Vigo started to be part of it. I completely trust in the potential of our consortium. I think members of the Athena University, they are real well recognized institution in their expertises. So I think that all these activities they contribute to put Athena in the front of the internationalization that the framework that we are now. So as Professor Kostas said, my name is Iago Pozo. I am a senior researcher at the University of Vigo. I am mining engineer working on conservation of cultural heritage. Always some people are surprised that a mining engineer work on this field. So I would like to explain you why I am working on it and why I am able to do it. As a mining engineer, I have knowledge about raw materials, such as minerals, such as stones. I know how to characterize these materials. I know I have the necessary knowledge on physics and chemistry to evaluate what happens to these materials when they are used to build our tangible cultural heritage, for example, statues, for example, paintings, facades. So I can work as a conservation scientist, and I can work closely to other professionals such as conservators, restorers, archaeologists, etc. So first of all, I would like also to introduce the group which I belong. This is my small group. We work in a bigger group, which is HESMIN, is Safe and Sustainable Management of Mineral Resources in the University of Vigo. We are professor, postdoc, and PhD researcher from different fields. We are biologists, engineers, conservators, physicists, chemist also, but it's very important. I always try to highlight that research on protection of cultural heritage is a field that has to be researched with a multidisciplinary and interdisciplinary approach. We have to work together because in cultural heritage we can gather different knowledges and different disciplines. So it is very important to work together and to state collaboration with international and national institutions. For example, in our case, we work with Spanish universities such as Granada, Coruña, Valencia, but we are always worried on the trying to state new international collaborations. As Costa said, we have collaboration with the Foundation for Research and Technology in Crete, in Greece. We also work with Italian institutions such as Centro Conservazione e Restauro La Venaria Reale. We have also collaboration with one of the most important universities in Portugal related with engineering, which is the Instituto Superior Técnico, and that belongs to the University of Lisbon. So it is very important to try to bring together to your field people from different institutions and different research groups, because together we can do things bigger. So starting with the topic, starting with one of my research. First of all, we know, all of us, we know that we have fantastic monuments, fantastic statues, fantastic elements of cultural heritage in our cities, in our countries. But unfortunately, our cultural heritage built in stone is exposed to acts of vandalism, such as the uncontrolled application of graffiti, as we can see here in these photographs. For example, in the left part, in the upper part of the slide, we can see a photo of one of the statues of one of the facades of the Cathedral of Santiago de Compostela. One morning in 2018, this statue appeared like this. On the lower part, we can observe also monuments located at Central Park in New York, that they were also vandalized with paintings. So unfortunately, we have to say that sometimes our cultural heritage is sad. It's sad because the human being, they have behaviors that they shouldn't have. Yeah. So we need, first of all, we need that the people think about the important to work in the maintenance and to conserve our cultural heritage. But unfortunately, if some people make these kind of things, we have to start to think in strategies to clean these applications, okay? So when we want to clean cultural heritage, we have to keep in mind some of the requirements that we have to follow. For example, the cleaning should not cause damage to the original material, such as abrasion, microfracturing, porosity increases, dissolution of the materials, color changes. Also, the cleaning has to be gradual. I mean, we are working with fragile material, so the operators must regulate the intensity of the application of the cleaning procedure. Also, the processes has to be selective. It means that the operator will be able to limit the application. I mean, sometimes you need to clean some part of the monument, but in the other part of the monuments, very close, you cannot use the same cleaner or the same cleaner processor. So it is necessary that the operator can stop immediately the application of this cleaning strategy. Also, and as you can imagine, also one of the important requirements is the cost of the intervention. Okay, this cost should be affordable. And in this cost we have to include the cost of skilled labor, scaffolding, techniques, and product use. So these factors, they are factors that should be in mind when we want to design a cleaning strategy for some monument or some element that we need to clean. In this slide, we can observe photographs of different cleanings, specifically traditional chemical and mechanical methods. In the upper part of the slide, we see photos of laboratory tests. On the right, we have the application of mechanical methods. Here we have the application of a method called hydrogomas, which is the application with low pressure of a mixture of water with this small silica sand that we can see in the photo in the scanning electron micrograph that we have in the right part of the slide. The advantage of this method is that we apply the mixture under a very low pressure. On the left part, we have the application of chemical products to clean graffiti, and in the lower part of the slides, we have real cleaning processes that we apply in different monuments. On the left part, we have a chemical cleaning of one of the most important statues in the Palacio da Ajuda in Portugal, in Lisbon. And on the right part, we can see the application of mechanical cleaning also in one of the monuments located in Lisbon. However, these processes that they usually have some drawbacks or some problems. In the case of the chemical methods, here on the right part, we can see a micrograph taken with a scanning electron microscopy. This is a granite surface that was cleaned of graffiti with a commercial product. And unfortunately, after the cleaning, we can observe that on the surface, we have powder rich in copper and sulfur. These elements came from the cleaner that we apply, the chemical cleaner that we apply to extract the graffiti. So one of the drawbacks that we can have with the chemical methods is the chemical contamination or the existence of secondary products that we can obtain when the product that we use to clean react with the layer that we want to extract, to clean. Also, in the case of the mechanical methods, we also have some problems because when we apply mechanical procedures, even at low pressure, as I commented before, in the case of the hydrogomas, that is a process that is applied with very low pressure, we even obtain an increase of the roughness. I mean, it means that we are taking out material from the stone. So this is something that is totally forbidden in the field of cultural heritage. We cannot affect to the material, in this case, taking out material from the stone. Okay. Also, we can see here that after the application of hydrogomas, we obtain this kind of roughness increases independently of the color that we are taking out. Even in the case of the red color, the increase of the roughness is bigger than in the rest of the color graffiti that we apply. So even low pressure methods, they can affect to the surface because we are performing a roughness increase, which is connected with a loss of material. So in this case, we have to start to think more. And in order to solve this problem, in the 70s, more or less, laser, and as you know, laser is the acronym of light amplification by stimulated emission of radiation. Laser start to be used in the field of cleaning of cultural heritage. Here, the man that is in this photo, John Asmus, he was the responsible of all of this. Okay, he started with this new field of research inside the cultural heritage conservation. We warmly call it to John Asmus as the grandfather of the laser cleaning, and how he started to clean with laser the stones belong to cultural heritage. He was in Venice making holograms with his laser. He was working with different sculptures, with polychrome wood carving, with different stone statues. And when he was inside the museum making these holograms, suddenly it started to rain. Then when the rain start, the water start to go through the window to the room where they were, and the water start to splash on the surface of the artworks. So he called to the conservator of the museum in order to cover the artworks with a plastic because the water was inside the museum through the window. So when they were covering all the artworks, the conservator said to him, "Why you don't help me to preserve the stone sculptures of marble? Because all of these sculptures made with marble, they start to have a very thick sulfated black crust, very black crust on the surfaces." And then Asmus say, "Maybe I can help you." So the idea that he started in that moment was to try to focus the laser on the surface of the monuments, of the sculptures, and then he realized that the crust start to be ablationated. The crust start to be out of the surface of the marble, of the sculptures. So this was the moment that the laser start to be applied on conservation of cleaning heritage for cleaning. After that, the research on this topic never stops. Currently, we can find many scientific works about laser cleaning on stones, on site and in laboratory, and particularly these works are regarding to carbonate stones. It means limestone, marble. Why? Probably because in the countries that the people start to work more on research for this new technology for cleaning cultural heritage, they have cultural heritage made with this kind of stones, because these countries, they are Italy and Greece. They start to work on cleaning with this kind of new technology. And also it's important to highlight that marble, limestone, they are characterized to be very homogeneous. They have a very composition, very homogeneous. They have a very homogeneous color also, and this help to the laser to clean. In the case of the granite, we have some problems, as we can see in the next slides, because granite is a heterogeneous rock. We have 4 or 5 different minerals, and we have 4 or 5 different colors. So the laser acts in different way to each of these minerals. Laser radiation, the characteristic of this radiation is that it is a monochromatic radiation. It works in the same wavelength. It is coherent. It means that we have the same vibration frequency. We can concentrate the beam in order to have high energy. And when we work with lasers in cultural heritage, we need all the time to try no, we need to optimize, not to try, to optimize the parameters that we have in the lasers before to apply the laser in the real artwork. So the parameters that we need to know when we work with lasers is the active medium that we have. It means the crystal that is the responsible one to create the electrons that we have in the laser. This active medium can be neodymium yak, neodymium yttrium, titanium sapphire, erbio yak. We have different kind of lasers. Also, it's important to know the wavelength that we are using to extract the different deposits that we can find on the surface of the material. The fundamental is 1064, but we can work with other of the wavelength that we have. Also, it's important to know the pulse duration that we have. As you know, we have two groups, the continuous ones and the pulse lasers. In the case of the continuous ones, we have, for example, the CO2 laser. This laser is not very recommended to apply in conservation of cultural heritage because we have a very important thermal effects on the surface. So we will get fusion, melting of the minerals and also of the deposit that we want to clean. And also, and in the case of the pulse lasers, we can work in a wide range of pulse duration, from microsecond until femtosecond. Also, it's important to detect the correct fluence that we want to apply. It means that we need to determine the threshold fluence that we need in order to avoid damage to the stone that we have underneath the deposit that we want to clean. And also, it's important to know the fluence that we need to start to extract the coating or the deposit that we want to remove, to eliminate from the surface. And also, it is very important all the time to have very clear the characteristic of the deposit that we want to clean. This deposit can be graffiti, biological colonization, sulfated black glass. We have different deposits that we need to characterize in order to select a very good parameters for our cleaning. Before cleaning a real artwork, it is very important to perform tests with the available lasers in order to achieve this optimization that we were speaking before. We can, for that, we can simulate the deposit or the patina that we want to clean in the lab. For example, imagine that we need to clean graffiti on a marble, so we can do samples in the lab in order to do a test and to select the best conditions. Or if it is not possible to perform this test in the laboratory, we can work in situ, but it's very important to start with a small test in the artwork in order to see the best option. This first approach will allow us to know the damage threshold for our stone, which is very important to know the moment that we start to make damage to the surface. We will determine also the extraction threshold for the substance that we want to remove, and also we will determine the right combination of the parameters to extract the substance that we need to extract, but avoiding any damage to the stone that we have underneath. So here, I would like to show you some difference that we've found during these years related with the application of different laser sources. Here, we can see the importance of the active medium that we have in the laser in the result that we obtain. In the photos taken with scanning electron microscopy, we can observe one of the most sensitive minerals that we have in the granite, which is the biotite, because it's the mineral that has the lowest melting fusion, so is the first mineral that start to have damage on the surface. One of the surface was irradiated with a nanosecond pulse duration neodymium jack that was at 1069 nanometers, and the other one it was irradiated with a microsecond pulse duration Erbio jack that was at 2940 nanometers. These lasers were used to extract a weak biofilm composed by algae and cyanobacteria on the granite, and as we can observe in these micrographs, the results in terms of the extraction of the biofilm was they were satisfactory, both. However, in the case we have difference in the effect of these lasers on the minerals. In the case of the neodymium jack, we found very little damage on the surface. We can observe here with arrows some fusion of the planes, the exfoliation planes of the biotite. However, on the surface of the Erbio jack, it was clearly identified a crust of fusion on the planes of this mineral. It was not possible to identify the different exfoliation planes of the biotite, while in the case of the neodymium jack laser in the other slide, it was possible to see the difference, the different exfoliation planes that we have on the biotite. It is true that in this case, we have to consider that it's not only the active medium that we have, because as you can see, we also work with different pulse duration, which is a very important parameter also when we want to extract this kind of biofilm, this kind of crust on granite, on stones. So here I would like to remember that it's very important to keep in mind that in cultural heritage it's mandatory to avoid changes in the minerals of the stones, because we don't know exactly how these changes will affect to the durability of our artwork. So it is necessary to try to diminish or to decrease or to totally avoid any change in these kind of minerals, because we don't know what will happen in the future with them. So here, regarding the effect of the wavelength on the cleaning effect, here we have the example of the cleaning of the graffiti with different compositions. We have blue, black, and silver graffiti with different composition, different inorganic pigment, and different binder. And these surfaces, they were cleaned with a neodymium jack. This neodymium jack is placed in the fourth in the Foundation for Research and Technology at Crete in Greece. This laser has the peculiarity that can work at two different wavelengths simultaneously. It means that we don't have to work first with UV and then with infrared wavelengths. No, we can apply together at the same time both, which is very useful, because we can decrease the fluence that we are applying on the surface. So we can take advantage of this possibility. And in this case, the laser has a pulse duration of 6.5 nanoseconds. So, following our methodological approach, first, it was necessary to determine the damage threshold of our granite. And when we have the fluence that we need apply for each wavelength in order to avoid damage to the granite, we can start to determine the extraction threshold of the graffiti. In this case, we work with 3 different graffiti. For this, we only have to apply the graffiti on a glass and then try to extract the graffiti with the low fluence possible, because we don't want to apply higher fluences in order to, because we don't want to make damage to the surface. And it is important to notice that for the graffiti, the lower fluence that we select was the same for the C graffiti. It was the lower fluence that we can apply with this laser because the extraction threshold is defined as the fluence that start to induce physical changes in the deposits. I mean, and with a small fluence, we can observe already that we start to have some alteration on the surface of the graffiti. Here, you can see photos taken with stereomicroscopy, and you can see that we can perform satisfactory extraction of the blue and black graffiti. In the upper part, we have the results with for the blue graffiti. We have good results with the UV radiation and with the combination of both radiations, but the results for the infrared radiation was not really good. We have some bluish deposits on the surface. But in the case of the silver, it was really difficult to extract. We could extract the pigment, the silver pigment, which were aluminum particles, but we had a problem with the binder because, as you can see on the surface, we can see like a glossy film on the surface that it was not possible to extract with the laser that we work. So here it's important to highlight the importance of the characteristics of the deposits that we want to extract. So we cannot generalize. We cannot say we can use this combination to clean this kind of stone. No, each stone has to be clean with the parameters optimized. Consider the thing that we want to clean. So it is very important to do first test in the lab or a small test in the artwork that we need to clean. The best results in this case were obtained with the application of the UV radiation and also with the simultaneous application of both wavelengths. In the case of the application of the both wavelengths, even we could decrease the damage to the minerals because we work, as you can see here in the photos, we can work with lower fluences than the ones that we need to apply with the UV radiation or infrared radiation. So regarding the other parameter that we have to keep in mind is the pulse duration. This is one of the most important parameters that we have to take in mind when we want to face a cleaning of a stone belonging to cultural heritage. In these lasers, the ablation process involves a combination of photothermal, photochemical, and mechanical effects. So we need to evaluate the beam, the laser, in every kind of a stone in order to determine the best options. As we can observe in the scheme on the left part of the slide, once laser is irradiated on the surface, we will have reflection and absorption of the beam. As a result, we will have heating and melting of the surface of the deposit that we want to remove. As a result of this, the surface of the deposit that we want to eliminate will start to suffer decomposition, and finally the substance will be vaporized. Then we will have the formation and expansion of a plasma, and finally through hydrodynamic phenomena we will get the ablation of the deposit that we want to extract. So we could achieve a satisfactory cleaning following these processes. It's also important to say that the shock of the waves, together with the transmission of the heat into the material, can can do that we have or we left remains on the surface, and even these remains can be melted, and also this transmission to the stone can also induce the melting of the minerals, as we saw before. In the case of the pulse duration, here we have two of the lasers that we work. They are nanosecond pulse lasers. One neodymium yttriovanadatu working at 355 nanometers, and the other one is the laser that I saw before, is neodymium YAG that works at 355 and 1065 nanometers, means ultraviolet and infrared wavelengths. And in these cases, for example, here I put a video as we work in the lab in order to perform the cleaning with the fixed laser that we have in the lab. Here you can see that the sample is moving and the laser is fixed, so we can apply the spot on the surface of the laser or of the stone. So here I saw you some of the results that we obtained with scanning electron microscopy. On the left part, we have the reference granite in order to see how these original minerals looks like. The quartz, the plagioclase, the biotite, that they are minerals in the granite. And on the right part, we have the results after cleaning blue graffiti on this granite. As you can see, in the case of the plagioclase, you observe perfectly the fusion of the mineral following the path of the laser application on its surface. We can observe also the conchoidal fractures of the quartz that we have when we apply the laser, and the most the saddest influence of the saddest symptom that we have in the granite, which is related with the biotite, because I say before is the most sensitive mineral in the granite, is this crust, this fusion crust that we have on the biotite, because we totally lost the exfoliation planes that this biotite has, as we can observe in the reference, that we can see perfectly the different exfoliation planes of the granite. In the case of the irradiated area, it is not possible to see these planes. So we need solutions. It is true that we can clean, we can work very hard in order to perform a very nice optimization of the surface of the laser application, but we need to be more comfortable when we want to apply laser on cultural heritage. So in this case, we have these other lasers that is related with the pulse duration that they have, and is ultra short pulse lasers. They work with pulse duration of pico and femtosecond. So they are quite faster than the nanosecond, and they work in different way. In this case, the extraction is done by the ionization of the atoms and molecules from the surface of the deposit that we want to remove, and as a result we have a plasma that is expanded at the end of the pulse, and we don't have the transmission of the heat to the stone. So we avoid the thermal effect, or we almost avoid the thermal effect on the mineral. Here, I will show you some micrographs taken with a scanning electron microscopy of some samples that they were cleaned with two lasers, one femtosecond titanium sapphire, and a nanosecond neodymium yttriovanadato. They work at the same, more or less at the same wavelength, but the results, they are totally different. At least in the case of effect in the biotite and the feldspar. As you can see in the left part, here we have the original exfoliation planes of the biotite. We can see perfectly the different slides. And then after the application of femtosecond, we can see that we obtain a micro texture surface of the biotite, but in some places it is possible to observe the exfoliation planes. In the case of the biotite irradiated with the nanosecond laser, it was impossible to see any lamination plane. They were totally melted, and they are like a crust of biotite. And the same happened in the case of the feldspar. As you can see in the down part of the slide, the feldspar has this kind of texture also in planes, and after the application of feldspar we have some micro texture, but in the case of the nanosecond laser we already have fusion of the surface. So recommendation: we need to know the advantages and disadvantages of each laser, so it is very important to have a carefully previous reading of scientific information, papers, books, speak with people that who knows about this topic. It's essential to optimize the parameters of the available lasers before applying the laser directly to the artwork. And if laboratory tests are performed, if tests are not possible to perform, a small test must be performed in the artwork in small areas in order to detect the best options. Future lines. We are working now in a new project that is related to the application of different sources of laser in pictorial heritage. Is quite difficult because we are working. The project is called Lasering. We have web page if you want to see more information about the project. But the application is more difficult because we have tempera paints with which are mix of an inorganic pigment and organic binder. So we have to keep in mind that we don't have only something that is inorganic. Now we have also something that is organic: egg yolk, rabbit glue, the binder that we use to perform the tempera paint. If you take a quick overview of the scientific articles devoted to the cleaning with laser of pictorial heritage, we will find a very few, 16, 20 articles, which is nothing in our research field. And even the information about what happened to the pigments and to the binders when they are irradiated with laser, this information is even scarcer. It's even we don't have we have little information about these processes. So the objective of this project is to know the effect of the laser radiation, working with these parameters that I said before, the different active medium, different wavelengths, different pulse duration on the pigments and the binder, and also in the whole system, in the tempera paints. We have to also to identify the laser irradiation parameters suitable for the removal of dirt on this kind of painting, because usually they have like dirt made by carbonaceous particles, metal elements that we have in the environment, that they are deposited on the surface of these artworks. So we need to find the good option to clean with laser. And also the most important thing is to transfer this result that we will get in the lab to a real artwork, to the industry and to the companies. So to finish my presentation, I also encourage you to try to look for information about this Congress, Technoheritage 2024. This Congress will be in Santiago de Compostela in September in the next year. So I hope that you can send some of your abstract in order to present your contribution in the Congress. The call of abstract will start in 1st of December until 29th of February. So please, would be a pleasure if you can send some of your research to the Congress. And this is everything. I hope that I am on time. Costas, I would like to thank you again for your invitation. It is a real pleasure to contribute to Athena activities, and I am here to answer all your doubts and questions that you want to tell me.
Muchas gracias, Santiago. It was
Okay.
very nice. Now the floor is open for questions. I have some questions, but I should wait until
Okay.
the audience will ask their questions. If there are any, I will count to 3. Okay. So Manolis, the floor is yours. Thank you.
Santiago, thank you very much for a
Thank
very
you.
interesting presentation. I can understand that this is a very multidisciplinary approach.
Totally.
So,
I
what you
mean,
consider to yourself to be a laser expert, material expert, or a
if I
conversionist
honest,
expert?
I mean,
Or all three?
if I honest, Costas always say photonics man, photonics people, but I mean, I think that I am more conservation of cultural heritage person. I mean, because I work with laser, but I also work with another kind of strategies, consolidation of stones, application of water repellent on the stones. So laser, it's a very, I mean, it is true that it's a field that needs to be more I mean, with more information, more work on it, because it's difficult to find the best conditions for everything. So it is very important to work on it, and I think it's a research topic that needs more people working on it.
Okay, thank you, Santiago.
It's okay, Manolis.
So I will start my questions.
Hmm.
Probably related to what Manolis has mentioned, but in another dimension, because using a tool does not make you an expert. But let me continue. My question on this: how much time does it take for someone that is not is not a laser physicist, for example, like one of these people that they develop the systems? How long does it take for an engineer, for probably an archaeologist to learn to use? But when I said to learn to use, like also to understand, the measurements in this topic, how long does it take the training?
Okay, first, the construction of the lasers that we have in the laboratory, they were made by physics. Okay, this is a field that it has to be done for the qualified professional, yeah, and they were made for physics and they work on it. In the case of the use and application of the laser in our samples, it means archaeologists, conservators, even engineers that they are not familiarized with the laser technology. I think in 1 year, for example, in our PhD student, I think that in 1 year, they already know how the laser works, how are the parameters that they are essential in order to work with this kind of material, because this kind of material is not it's a fragile material. It's something that we have to keep in mind when we want to clean. So it's not as you can apply the laser in a metal, in a normal metal, or if you want to texturize some plastic, for example. Yeah, here we need to know how we will affect. And so we need, first of all, we need time to understand how the laser work, and then we need also how you need to evaluate the effect of the laser on the surface. So our PhD students, more or less in 1 year, they are able to understand the process and to see if the laser start to be if the laser is correct for this application.
And this is like, I thank you very much for your response. And I can see, comments from our colleague Panagiotis Ignatiadis that this is also an excellent topic for upskilling or reskilling, of the people working in this topic, or other people that they would like to be integrated and, work on this topic. Also, I can see a very nice comments from our colleague Professor Kakavelakis about your presentation. I will continue my questions because I have other questions as well. So it's a very nice process. Okay, so you're sending the laser pulse, depending the duration, the parameters, the fluence, of course, depends on the target, on the substrate as well, on the thickness of the target as well. So I would like to ask you, in vivo, how can you check that you are not removing, the material, the substrate, the deposition material behind, the transductors, because you can remove using the wavelengths, and you're using 1064 and, how can I say, the multipliers of these wavelengths, the harmonics of this wavelength. But during the process, what kind of security and safety you have in order to check that the process will stop here, because then I'm damaging the substrate?
Okay, this is a really good question, and it's a very important question. So if you apply the laser in the field, on site, you need a technique, another technique to evaluate how you are working on. I mean, how the process is working at that moment. So we usually work with hyperspectral cameras in order to see how the process is going on. I mean, the naked eye is very well, but we have some limitation with that. So we always work with a small microscope, Dino microscope. I'm sure that all the people know this kind of portable microscope that we use, that it's very small and you can connect to the computer. And we all the time try to check all the cleaning with that. And also we try to apply different processes, different techniques, for example, the hyperspectral camera. We have some papers about the combination of laser cleaning with hyperspectral cameras in order to evaluate the process. So you can search for these papers. But this technique, hyperspectral imaging, was really good because we could obtain a parameter, a coefficient, in order to see the coefficient we call cleaning level. And this coefficient tells us when is the moment that when your reflectance curve is the same as the reflectance curves of the granite. So you have, first of all, you have different curves. You have the granite here, and then maybe you have the black crust here with different bands and different features. So you start to clean, and simultaneously you have to start to take images with the hyperspectral imaging, multispectral, whatever, spectral imaging. So you will see how your curve, your spectrum, will be closer to the spectra of the granite. In the moment that your spectra is super close to the spectra of the granite, you have to wait, you have to stop.
This, okay, please go ahead, Santiago. Sorry.
If you say, okay, I think that I can go more, I think that I can go, be careful, because sometimes the spectra that at that moment was really close to the spectra of the granite, then this spectra will change, because if you start to make damage to the surface, it means you will start to make color changes in the stone. You will start to extract material from the stone. The spectra change. So it is a very good information during the cleaning process.
And I suspect that machine learning and artificial intelligence also could play an important role in this, in order to train the system, after a lot of measurements, of course, by taking into the account the laser that you are using, the thicknesses, the substrates, train the system to stop automatically, in the future. I don't know a lot, I don't know anything about this, but following other discussions, I can see, a lot of space knowledge on
totally.
that. And
Because
I have another question. Like, I suspect that all these laser cleaning processes, at the end of the day, they should be combined with mechanical or chemical processes, because you are not sure about 100% of your results. So I would like to say to you over there, what is the technique that you combine this initial laser cleaning? Is a mechanical one, the classical one, or the ultrasounds also can play an important role, because you can couple, the laser head with some ultrasound head in order, simultaneously to try, to do the job.
I didn't work with ultrasonics yet. I have to. I try in the beginning of my PhD. I tried to do it to clean sulfated black crust, but it was really difficult. I applied ultrasonic, but I didn't check. I didn't see anything. But it is something that it is in my mind. In order to compare the results of the laser, we also try to apply some traditional method, such as chemical or mechanical, in order to compare, okay? Because we don't say that laser is the best option. Never. We say we have this situation.
Don't say these things. Always lasers are the best option. Don't say
no. We have always to compare and to select the best option. Yeah. So it is important to compare the traditional ones and the laser. And in the last, I think it was 2 years ago, we also start to combine methods. Apply first chemical cleaning and then laser, and apply first mechanical cleaning and then laser, and change the order also. First laser and then chemical cleaning, in order to see how we can improve the results. And I have to say that the results, they are better.
Excellent. And my last question, I have 2 more. I will be very fast, because at the end, I'm keeping the people busy and they have other things to do. Is like, how tunable? Because I can see that you said that, you're using 1064, but sometimes the composition will change and you need your laser to be some kind of, to demonstrate some kind of tunability. So I would like to say, like, how tunable are these lasers that you are using, and what is the future of optical parametric oscillators that through them you can tune all the spectra on this application?
I mean, it is true that we usually use the wavelength that the system gives us. I mean, 1064, 32, 233, and so on. But the wavelength is very important. In fact, one of the first thing that we do when we have a new deposit that we have to clean is to obtain the reflectance spectra, in order to see the wavelength where the substance absorbs more. If so this is like the first approach that we have. If the spectra, the reference spectra, absorbance spectra of the substance say that 1064, this deposit has a good absorbance, we can apply these lasers. But sometimes we obtain that the best option is in another kind of wavelength. So this is very important in order to develop the technology to try to obtain the specific wavelength that it is better for the absorption of the substance.
And my last one, and I stop here, I promise, is like regarding the time scaling. I mean, you have the mechanical process, you have the chemical one, and you have the optical. Can you give us an example of, a material, a cultural heritage item? How much time does it need in order to be cleaned? 100% using this one, or this one? Of course, we have understood from your presentation that we need the combination in some times, but if someone would like to check and invest his money, what's your answer on this question?
I mean, in the case of if you have a wall that the historic and artistic value is not, it's not so. A wall, I mean, I say a stone wall, okay, that is not a very high value. So you can use chemical and mechanical processes, but if you have some historical monument, in order to clean, imagine that you have a statue or you have a monument, you have faces, you have fingers, you have nose, you have mouths. So in these cases, it's recommended to use laser, because if you apply something that is applied with pressure, you will damage the surface of the stone. Imagine that you are cleaning a nose in an angel, and then you apply a very low system with pressure, so you will maybe lose the nose. So it is important to see the system, to see the monument, to see the surface, and also to see the deterioration state of the stone. Because if you have a stone that is already very deteriorated, that you can see sanding, you can see sugaring, which is the sanding of the stone, you cannot use any mechanical procedures, because you will make more damage to the surface. So it is important to know the surface that you are cleaning. Okay, if you have to clean something that the value, the historic and artistic value is not high, you can use the mechanical one or chemical one. But if you need to clean something that is that has a very important value, you need to apply laser or try to apply a combination of process.
Excellent. Thank you very much, Santiago. Muchas gracias. And from all of us, from the two Georges that we try to organize from on behalf of the Athena, we would like to thank you very much for your input. It was very informative and very well-structured presentation.
Okay.
Next week, for the rest of the people, we are going to continue these activities. Next week, we have two speakers from the University of Leuven in Belgium, and they are going to speak to us about space and geodata to foster innovation and create new job opportunities. This is a new topic, how to exploit, the massive data that we receive from extraterrestrial in order, to improve a lot of processes on the Earth. So until that moment, I would like to thank all the participants for your participation, and particularly Santiago for his contribution. Santiago, we're expecting your answer as soon as possible, and we are looking forward to meeting you again in these activities. Have a nice weekend, and speak to you soon. Bye.